Start.
Welcome to the fourth practical stream after the 2-week pause. We call the stream today Storing Data in C2, but actually we have many things, different things planned today. So we'll look at how to actually compile your program. We'll talk about data types, that's why we call it Storing Data in C2, and we'll look at the stack again. So it's definitely going to be an interesting stream.
So it's really the first time that we start programming in C today, so really start programming in C. So just one question in the chat: is everything working and are you understanding as well? Because then we really start, but we might switch already to the slides. Okay, that looks fine. Very good. Okay, then let's get started. But before we come to the interesting things Julia mentioned before, we need to discuss some organizational things. So the first thing that you should already have noticed is that the grading is available. So for homework 1, you can already find the points that you got there. And the link for the grading is available in the Teach Center as well as on our course website. So please check whether the points are there. And if you have any complaints, then please ask on the Discord. And in that case, please rename yourself on the Discord to your actual name. Otherwise, we have to guess who you are. Then the first block of the coding sessions. There, the grading is almost finished and it just remains to be uploaded, and this will be done approximately on the weekend. And homework 2 was due yesterday, and we have roughly 550 submissions, and yeah, this will need some time to grade it, but probably 2 weeks will be used past that you get the grading. Okay, that's for the grading, and then the coding sessions. We have some little change here. So I think we announced that there will be 4 blocks in total, so you can register 4 times to coding sessions, and as we do not have that many registrations per block, we only need 2 weeks instead of 3, so we have an additional 5th block. You can register 5 times, but nevertheless, the first 3 times, the first 3 registrations will be graded, and everything you do in addition is just voluntary exercise, which we highly recommend, but it's you will not get any additional points in the practicals.
Just because I saw it in the chat, the maximum points for homework 1 was 3 points.
Yes. And
if your homework is not graded or there's something wrong, please write us a message on the Discord so we can look into that.
But the grading is not directly in the Teach Center. It's on coding.theograz.it/grading. So please look there if you see your points.
You can find the link in the Notion on the Teach Center, but not the grading in the Teach Center. It's a link in the Teach Center. Or you can also find it on the Discord on the announcements. I wrote a message 2 days ago, I think.
So we can also show it now here, maybe on the Teach Center, as everything is prepared. You have here the link for grading, but you have to sign in, and I think I'm not signed in, or am I? Oh yes, I am, but I have not got any points because I did not submit homework 1. I was a bit lazy. Okay. That's about the coding session. So if there are any further questions, please ask them directly on Discord that we see your name. And then there is one more thing today, which is quite important.
Exactly, assignment 1. So I saw you already asked in the chat, assignment 1 will be released today. There's a kick-off video. We won't be going into assignment 1 in the stream today, but there's a kick-off video which will be released on YouTube at 18:30. And the repository should be available by tomorrow. And yeah, I think that's it. If you really want, you can also look then in the upstream repository of assignment 1, which should be then available today with the kickoff video. And so there will be a question hour at the 20th of November.
So I'm not quite sure whether 4 p.m. will be really the time, but that's the plan currently. But this will be announced, of course, on the Discord. And I think there is one more thing that you want to say about assignment 1.
Exactly. So I have it open here. You will get this repository too. We have 2 test runners to test your code. And if you execute make test, everything about it will be explained in the video. It will execute a test runner, but if you use a Mac M1, so on ARM, you should execute the test runner ARM directly, because the normal test runner will not work on the Mac VM.
Yeah, that's the information for all Mac users.
Yes, so if you don't have a Mac with an M1 or M2 or M3, this is not important. You can ignore that.
Yes, and all other details about this repository will be explained in the video at 6:30. And as we have the question, how long do we have for assignment 1? It's roughly 2 weeks. But I think it should be really manageable to do it in those 2 weeks.
Yeah, if you don't start late.
Yeah, so I think that's generally a good hint. Rather start this week than in 2 weeks, 1 day before the deadline, and then you struggle and do not finish assignment 1, which would be.
So if you struggle, then you can still ask questions, and sometimes it takes a bit until you answer them. So if you start directly before the deadline, maybe you won't get it done. So it's better to start early.
Okay, I think that was everything about organization. So let's continue. And from last time we had, I think, 3 Menti questions left. So you can find the link in the video box and also the code. And that's where we start. Maybe we switch to the first question. And already some of you are logged into Menti.
So there will only be one more homework, which I think is at the same time as an assignment. But in general, you now have to concentrate on the assignments and not the homework. So yeah.
And don't start too late. Question hour 2 days before the deadline. Yeah, experience tells us that if we do a question hour earlier, nobody attends it. So we don't offer a question hour earlier. However, you can always ask on Discord. And if you have any other trouble, I might show this here as well, where we wait for the Menti. On the Teach Center, you can also register to the personal question hours here below, where you meet with a tutor and can ask him or her questions. Or if you have any problems, then please use it. I think by now only 1 registered for all the personal question hours. So particularly for the assignments, please use them and register to that.
If you forget to hand in your report for the coding sessions, they will not be graded, and it will also count as an attempt. But we have some guidelines we follow, so if you ask on Discord, we can tell you in your particular case if you get the points or don't get the points.
Okay, that were all questions, right?
I think so, yeah.
Then we start with the first Menti question, with the first question from our side. And you see some code here. Some short function, some conditions, and now you should tell me the output of the program, whether it's if, whether it's else, or something completely different. For example, it doesn't compile, for example, because we have some problem. Do you have a guess?
Yes, I think so.
Okay. Okay, so else would be the right answer, but there are some people who haven't done it right, so maybe we have a look on the code. So we have that x is 42. So is x larger than 50? That's not the case. Is x smaller than minus 50? Also not the case. So this is false, and the OR of 2 times false is again false. So we do not execute the if but the else, and that's why else is printed to the output. Okay.
Okay, then let's continue with the next question. Okay, we have again a code snippet. This time it's a while loop. We have a counter and we decrement the counter in the while loop, and there's also a condition in the while loop for when it should stop. And so the answer is either 5, 5, 3, 5, 3, 1, 2 times 5, 4, 3, 2, 1, or none of the above.
I hope that the right answer is then both of them, if it would be the right answer. How did that happen?
So, yeah. Okay, there are a few got it wrong, so let's look at it again. I think that should be loops. Exactly. Okay, so we have this counter 5. And first we check, okay, is it not equal 0? No, it's not. We decrement it by 2, so it's 3 now. Then we check again, it's not equal 0, then it's 1. So from now we have 5, 3, 1, which is what most of you clicked, but then we decrement it again by 2, and now it's -1, and it's still not 0, and the loop just continues forever. So yeah, the correct answer would be none of the above.
So it's an endless loop. Yeah. So this was kind of hard.
Yes.
But let's see what the last question is about. Also something we did last time. And now we have some arrays. So there we have some array of size 5 containing the values from 1 to 5 and the sum. And we start with counter 1, iterate until the counter is 5, and whenever we do that, we add to the sum the element of the array, and then we print the sum. Now the question is, what is this sum?
Okay, yeah, we can then look at the last example again.
Yes. This was also hard.
It was a tricky one.
Yeah. So let's see first why the array example works that way it works, and then we have again a look on the loop. So the array contains these values. Okay, we counter equals 1, so that's the start, and now we sum, or we add to the sum, which is in the beginning 0. So we have sum equals 0, and my array at counter. Okay, and counter is 1, and my array at counter, it doesn't work here, but my array at counter, index 1, this is index 0, and this is index 1. So we start with the element 2, so the sum is 2. Then we increment the counter, so we get to the next element is 3, is 5, 2 plus 3 is 5. Next element, we add 4, so 2 plus 3 plus 4 is 9. And then when we add this element, it's the index 3, element 4. We increment the counter again. Counter equals 4. 4 is still less than 5, so we add also the element with index 4, which is the element 5. So 2 plus 3 plus 4 plus 5, which is 14. Counter plus equals 1 is then 5. And now we exit the loop and print the sum. So we added everything except for 1, which is 14.
So the tricky thing here was that you notice the counter is initialized with 1, and that you know that the array starts at 0, so the first element is skipped. And maybe
I have now an idea. We wait now for some moments until we show these examples again, but then we explain it in a better way where we really visualize what's happening with the debugger.
Okay, yeah.
Yeah. So stay tuned for for these examples. We will show them in, I don't know, 15 minutes. But then we have some examples that we can demonstrate with the debugger, and you will learn what this is all about.
Exactly. Okay, so let's start with the compiler. We won't go into any theory because you'll learn that later in the lecture. But for now, just how to use it and what it's about. We'll be programming in Visual Studio Code, which is this program here, which we already used last stream to show some programs. When you open a file in here, the first thing you should do is go to terminal and then open a new terminal.
Okay, so is this the same thing that we opened also in the virtual machine?
Exactly, that's the same thing we did in the virtual machine. So yeah, just that now we have it in here. You can also open it in a separate window, like we did it in the first, I think it was the first practical session, which is also fine. Okay, then let's try, I don't know, printing something. Oops. We're using a new keyboard every stream, so.
So I just want to answer two questions here. So yeah, in this terminal you can use the same commands that you can also use in the virtual machine. And basically you open VS Code or VS Codium in the virtual machine, so it's pre-installed there.
Yeah, it's already there.
So you just open, if you want to code with us now, you just open your virtual machine, start VS Codium, there should be a link on the desktop.
Yeah, and of course it's like most other programs, if you want to open a file, you can either drag it in there or click File, or open a folder where this file is. So exactly. So, but how do we now execute this program? Okay, so we have here now the code, and now we want to run the code. So of course the computer can read this code. So we'll use the compiler. One what it is in the lecture. So our compiler is clang, and we have to specify first where we want to, what's the output file of what we want to compile. So we want to compile main.c. So I'll call the output file also main. This will be an executable, and in Linux mostly executables don't have an extension. So I'll just call it main. And that's the same for in Windows, for example, a .exe file, which will generate, so something we can execute. And then we'll need to specify what we want to compile. So yeah, let's specify our C file and try to compile. So what happened now? This worked. We can already see here that we got a new file, main here. And if you want to look at it, it won't let us, because that's not a text file. That's a binary file which the computer can execute. And you can open it anyway. It's just it looks a bit silly, yeah? So it's not something, it's not text we can read, but the computer can execute it. And how do we execute executables? Normally, which you already saw here, we just type in a command and then it's executed. But if you want to execute a program which is not installed on the computer but in the current directory, we have to type // and then the name of the executable. And as we know from the first practical stream, the dot represents the current folder. So this is just a way to tell the command prompt that we want to execute the file main from the current directory. And what happens if we do that? We can press enter and see that we print hello. Not in a very nice way, because I forgot the \n, the new line. With arrow keys up, you can switch up and down, you can switch between commands you recently executed. So we'll be using that. And okay, we see hello is printed. Okay, so somebody wrote that's a bit fast. Now I want to show you some alternative perspective. What you have done by now was something like opening online GDB. I hope that's the right thing. So this was what we have shown before, and then you just okay, we have to select the language, which is C, and then you press run, and then you got the outcome of your program. And basically that's the same what we're doing here now, but we're using those two commands. So the first command is then this clang command that really compiles the file and creates this executable file, your program. So if you think about the program, this could be Firefox, for example. Yeah, if it would be large, but it's very small, a hello world.
And then this program gets executed with the second command, and then you get the output. And that's really the same as if you use online GDB, where this is done in the background and combined so that you really immediately get the output.
Yes, and online GDB does the same. If you click on run, it will translate or compile the file to some format which is readable to the servers, to the computer of online GDB, and then execute it. And display the result in your browser.
Okay, so this really worked fine.
But now the compiler can also tell us if things are going wrong. So let's try printing a variable. So I have called it test now and assigned the value 5 to it. Now I press the arrow keys up, compile it again. We always need to compile it if we changed something. And we see, okay, it's working. But what happens now if, I don't know, I make a typo here? So Visual Studio Code already knows that's wrong, but let's try to compile it. And we see, okay.
We get some error message here.
Okay, use of undeclared identifier test. Did you mean test? So it already knows what we did wrong. We wrote test here, but we meant to use the test variable. Then it's also giving us this nice overview where it's marking where things went wrong, and then it also gives us this note, okay, maybe we wanted to use this test variable.
But basically when you run this Clang thing here, you create that executable, but if that's not possible because you did something wrong, then Clang will tell you, okay, you did a mistake there. Please fix it. Is that right?
Yes.
Okay.
We can also hover over here, and then VS Code will give us a pretty similar error. So if Clang is not installed, by your error, I think you're using Windows. So you can also use it on Windows, I think, but we would recommend to either use Windows Subsystem for Linux or just use our virtual machine, which would be the easiest option. And there it should be installed.
Yeah,
it is installed there.
If you're not using the virtual machine, it does not need to be installed.
Yeah.
Okay, so back to the thing that we should be looking at. So we had this error where the compiler said, okay, please fix it.
And the compiler will tell us many different errors. Up until now, we always wrote this include. If you don't do it, you can try what happens. And we see, okay, it gives us just a warning for implicitly declaring a library function printf.
Whatever this means,
with this type. And then it gives us a note, okay, we should include the header or explicitly provide a declaration for printf. So it tells us, okay, we should either include the library or we should write a function ourselves, which is named printf because it can't find it. Yeah, okay, it's still working because it's included like by default, but it's giving us this warning that we should probably include that, and you should always include it.
So I can basically say if I run this Clang command and I do not get any output, then it should be fine. And if I get any output like a warning or some notification or an error, then I have to look on it and fix it before I can really use my program.
So you do get point deductions at the assignment if you have any warnings, because warnings most of the time mean there's something wrong with your program, or at least that there's something that doesn't make much sense. Maybe it works, maybe it doesn't, but...
So for example, we can think about the following. I just remove this printing of the test variable again. So we just have this program from before where we have the integer test and then the hello, but we do not do anything with this variable called test. Yeah, so basically it's a complete useless variable. Why is it there? We don't do anything with it. And now we run this Clang again, and in this case the compiler doesn't say anything because Why is that the case? It's a valid C program. Yeah, we can declare variables like here, but don't use them. That's fine. But probably you have done some mistake because you wanted to use that variable at some points, but you forgot to. And now it would be really nice if the compiler could tell us, oh, you did something wrong there, please fix it. And we can do that. And we can enable more warnings. So with the flag minus W all, and now this W stands for warnings and all for all. That means we enable all warnings, and this, the remaining part stays the same for the file that should be created, the executable, and our code. If you do it this way now, we get a warning.
Okay, maybe this is also something good to note here. If you get a warning, your program still compiled. So because now, okay, you could think, okay, I tried to run this program, but it failed. But you still have the executable from the last run. We can check, we delete it, try to compile it again, and we see, okay, we got a warning, but we still got an executable.
Yeah.
And it will work because it's a valid C program, but yeah, it just tells us, okay, maybe we have an unused variable. It's most often a sign something is wrong or we messed something up. And we can, oops. You can also show that with the last warning again. So if we delete the file, and then compile it, we get 2 warnings, one for the printf, one for the test, but it's still compiled and still works. Because warnings just tell you that there might be something wrong with your program, but it's still technically a valid C program.
Okay, I think that's the part about the compiler. I think we've shown everything now, but maybe we switch back to the slides to show it in some summary for you again.
Yes. So we just showed you this to get some overview of how to compile programs, of how to turn your C file into an actual executable. The theory behind what a compiler actually is will get presented today in the lecture.
Yeah, and to summarize now everything, what we have seen was here to compile the program, we using this command here with the compiler, the output file and the source file, and then we also showed you this WOR flag. And for the assignments, we will also use some additional flags here that will enable more warnings, but we will not go into detail of those today. Yeah. But the important thing is that you can compile with Clang. Probably you should also use WOR and the output file, the source file. And this is also something you will have to show us during the assignment interviews, that you're able to compile your program because you need it to actually code.
Okay, for the question in the chat, you can switch the order of the parameters around with clang, but the output name of the program needs to be after the -o flag. So this flag just specifies that the next parameter is the name of the output program. So these have to stay in this order, but everything else you could switch around. And you could use GCC instead of Clang, but we compile everything with Clang for the test cases, so you should stick to Clang.
Yeah, and by hand we mean that you type these commands here and do not press on the run button of, for example, some IDE or online GDB or whatever.
Or use a make file.
For example, yeah. So I would like to ask, how is the feeling in the chat? Was that kind of clear to you, or is that completely not understandable for you?
Okay.
But it's just those 2 commands.
Okay, so if there is some more in-depth tutorial, yes, later in the lecture. There should be more stuff about the compiler. For now, just accept that you can type in this command to convert your source code into something the computer can execute.
Okay, it looks good. So I was a bit unsure because we had some discussion here, but I think for most of you it should be clear. Okay, then we show you some other tool that you should also use, which is the debugger. So that's something that we can use now to clarify the Menti questions from before. Because maybe if we switch back to such a Menti question, so I probably take the loop now. If we run this now, so we can do that now, we can compile it with clang, okay, -WR for example, output file should be called Menti, and then Menti loops.c. Okay, we haven't included the standard IO. And if we run that program now, I called it Menti, then it would do something completely silly, which we already discovered that it's an infinite loop. But we would really like to see what the program is doing. Yeah, so we would really be able to start here and then go step by step through the program and execute each line one by one and visualize what is happening in the program. And that's why we use a debugger. What would you like to say?
Just because a question in the chat, like what the compiler does. I don't know how in-depth the lecture will get today, but I think then if you're interested in that, the coding sessions, which are coming up now or
next week.
Okay, yeah, they should be interesting to you because there you will get to know the compiler more in depth.
Okay. Yeah, one example would be to use printf everywhere, but yeah, we will have a look on something better, and that's the debugger. And if you're in the virtual machine, you can do it the same way as we do it right now. So the first thing, and I think it's pre-installed, you need here on the left side, on extensions, you need LLDB. I hope that's here. And you, here it's code LLDB, I'm sorry. This extension, you search for it and install it.
It should be already installed in the virtual machine.
Yeah, and if you're using it outside, you have to install it. So this is the first thing. And then the second thing is you go here to this little bug, which is there for debugging. And now we can select here run and debug, and we will get this overview, and we select LLDB. That's what we installed before. And we get an error message, which is completely fine. So press OK. And then we get this launch.json. And this is just a configuration file for the debugger. And we don't care about everything here, except for one thing. We have to specify in this parameter where the program is that we should execute with the debugger. And in our case, it was called Menti. So it should not be the code, it should be the executable file. Okay. You can also see in the overview of the folders that the launch.json in this .vs code folder. Yeah, you can always change it if you need to. But back to the run and debug section here. Then everything is set up and we can run our program, except for one thing. If you want to debug your program, you have to use an additional flag -g when compiling, which additionally adds some information that the debugger knows where you currently are in your program, because usually this information will not be stored because it's not necessary, but with -g we can really enforce that it is stored, and then the debugger can visualize where you are.
For example, then somewhere, somehow in the binary there would be stored that this printf here happens on line 9 of our program, and then the debugger can do stuff with that.
Okay, so we compile it now with this additional flag -g, and then we can just execute the debugger here on the green arrow. But before we press here on the left side and at the so-called breakpoint. So at this point we want to stop in the program and visualize what is happening. So we run it now. And now you can see we stop here with the counter being 5. And here on the left side, we have an overview over the variables. And currently the counter is here 0 because we have not executed that statement yet. So if we step over, then we see that the counter gets initialized to 5. And now we are in this while loop. So this would be the next command that is executed. What happens? The counter was not 0, so we go into the while loop and now we would print. And you can also see that, I think, in the terminal.
I think it's output or debug console.
It should be printed somewhere, but it isn't. Okay, we accept. No, it's not printed, but it's too hard now to explain why it's not printed here, but we could manage to do it. Nevertheless, we can monitor it here on the left side. And now we have this minus equals 2, and when we execute that, we see the counter gets changed to 3. We're still in the while loop, we go into the printf, would print it, which is not happening apparently. Counter minus equals 2, we go to 1, and then if we continue next round, we have minus 1, and we still continue in the loop, and we continue, and we continue, and we continue. Yeah, and that's why we do not stop. So we can really monitor what's happening in the program. Are there any questions?
Okay, so yes. If you debug without -g, the debugger has no way of knowing where you set your breakpoints, because debugger knows, okay, I want to stop at line 5, but if this information is not available to the debugger, it can stop there. If you want to know exactly what happens, just try it out. And if you really need to know why it's not printed, it has to do with buffering of std out of the operating system, which we won't explain now, but then maybe you can Google it.
If we would do it this, we don't have the commands here. If we do it this way, that we add this \n, then we would actually print it every time.
Yes. Now you see it.
And if it's too fast, you can always rewatch the stream and do everything step by step.
And maybe don't try to replicate what we are doing live, because then it could be quite fast. Because we have everything prepared, and maybe try to do that after the stream.
Okay, I think that's everything about the debugger, and we have to continue because we have much more that we have planned for today.
Okay, now let's go into the title of this lecture, more data types. Exactly, okay. So let's look at this example. We have two variables, one is equal to 5 and one is equal to b. Don't worry about the syntax now, that's the same as if you would do this.
Yeah, this is semicolon.
Oops. Okay, and then we compare a to b, and if it's equal, we print the a, and here we do it again, we compare. If it's not equal, we print no. Of course, a more efficient way would be to use else, but let's try it. Okay, and we see it's no, because of course 5 is not equal to 6, so this here evaluates to false, this is false, so this is not executed. And this here, so a not equal b is true, they are not equal, so this gets executed.
But that is clear. Why do we discuss that now?
Yeah, why do we discuss that? Well, let's look at the next example. What if we want to save the result of a equals b to a variable and then use this variable in the if? So we have this variable here, and then we use if equals, we do something, and if they don't equal, we do something else. So what is the type of this variable?
Somebody in the chat wrote bool.
Okay, I mean that's a good guess, but in C maybe not quite.
Okay, so some more Boolean guesses.
I mean, let's try and print it.
Okay.
So of course you can use the %d specifier to print values. Let's run it and we see okay. if something's wrong, we get 0. That's interesting. So maybe let's try if something true, so A not equal B, this should be true. Let's try and run it. Okay, now we get 1. So let's summarize. Apparently, Boolean expressions evaluate to either 1 or 0, and they evaluate to 1 if they are true, and 0 if they are false. Okay, but now if we have if they evaluate to integers, so what happens if you put in something else than 0 or 1?
So is 2 true or false?
Yeah, so because the type is an integer, we could theoretically do this. And now the question is, what happens now?
So is it true, is it false, or does everything explode?
Okay, many write true, so okay, yeah, that's true. And someone wrote greater equals than 1 is true.
What about -2?
Yeah, maybe it's just
okay.
Yeah. Okay, but what about -1? Okay, apparently that's also true. Minus a bigger number, that's also true. So actually we just learned that 0 is false and everything else is true.
Quite interesting.
It's interesting, and this this holds in C. So can someone suggest what data type we could use here now if you want to store the result of this Boolean expression?
And maybe as a little hint, by default there does not exist a bool as a data type in C.
Yes, of course, we could use char, we could use something else, we could use integer, we could use long. So every numerical value works. And yeah, by default there doesn't exist a bool, just wrote like bool in C. There are some efforts to implement this in the next C version basically, but currently there doesn't exist like a only bool data type or the constants true or false. Yeah, so there is a library you could include, but basically that's it. So
many of the students suggested char. Can we do that?
Yes, I can try it here now, but I can hopefully copy it over.
Yeah.
Okay, yeah. So let's try char.
All good.
Okay, and now we get the no, which we expected.
Because they're not equal, right? Yeah.
Yeah, because they're not equal. So equals would in this case be 0. And this means if 0 is false, because 0 is false, and then this won't get executed. And if not false is true, so this will get executed. Maybe something I just thought of which could be interesting. What if, let's print equals.
So it should be 0 now, right?
So, okay.
Yeah.
Maybe I put in a \n, but you can see here's a 0 now.
Now let's predefine it. Okay, we get the 0.
0. What happens if we type not 0? Because it's basically 0, so what is not 0? And we see that it's 1. So, yeah. If we type not 1, we get 0. And if we type not some other number, we get also 0.
But if you put now a second exclamation mark in front of 1, 2, 3, will it be then 1, 2, 3, or will it be 1?
So we have 1, 2, 3, then we say not this, and then not again. So it's 1 then, because not 1 to 3 is a true value. So it's a value that represents true is 0, because 0 represents false. And then if you do not 0 in C, so not false, it is true, so it's 1. Yeah, so if we replace D with C, you can try that out for yourself. Yeah, I think that's the second practical stream which would have covered that. So maybe you can also check that out again.
Yeah, not 1, 2, 3 is 1. Yeah, we did some math with exclamation marks.
Yes.
I think that's it about Boolean expressions.
So yeah, I hope this was clear. So if the thing we did at the end is not perfectly clear, that's okay. Just think about it afterwards. The main takeaway is that in C, there's not like a special value for true and false. It's just 1 or 0.
Okay. Then we come now to another very important part, which is will be a question for you on some code snippet, and we will cover the topic now: how long do variables live in a C program? And we start with some example. And please do not spoil it in the chat because it's a Menti question. Yeah. So we'll show you the code now. So something very familiar to you, we have some age variable, and if the age is large equal 18, then we say, okay, we have an adult, and otherwise we have no adult, and then we want to print this character to the standard out.
So don't spoil it, Menti question.
Okay, so yeah, you are free to answer the question here, and we will open the code for you. And there are some possibilities on yes, we have an adult, or no, there is no adult, or something completely different. Let's see what's happening. And I don't have it. Do we have a good feeling when the time is over for the Menti question?
How long is the question? 30 seconds?
Yeah, something like that. Maybe we switch over.
Okay.
Oh, yeah, something terrible happened there. Yeah, and that's something that we will discuss now, because we want to see how long do variables live, and in our case, we probably have a problem here with our variable. So we maybe compile it now next and see what the compiler says. So this is now the same, or maybe I will just copy it and put it in here and include stdio. And if we compile it, then it says, okay, use of undeclared identifier adult in this line 13 here below, and also the Visual Studio Code marks that we have a mistake here.
I have a question now.
Yeah.
My magic slide compilation and execution program reported more, like printed out more than we have here now.
Yeah, probably some warnings, right?
Yes.
Yeah.
So why is it different?
Because you enabled some warning flags, maybe?
Yeah.
Okay. Yeah, you enabled warnings and error, and we did compile only with the warning.
So as we saw before, unused variables are warnings. If you enable the WAL flag. But why are they unused?
Okay.
Let you continue explaining.
Now I explain it. Yeah, and it's a very simple explanation. Variables do only live in the block where they are declared, and in all inner blocks. So this means this character adult only lives within those two brackets. Yeah, only in this block here. And also this character adult only lives in this block here. And if we exit the block after the else, then this character does not exist anymore for us, and we cannot access it. The age is declared in this most outside block, so this integer age is available in throughout the whole function, the whole main function, and it is also we can also access it in all inner blocks here and here. in contrast to adult, which we cannot access outside of the block. And this is this very simple explanation, actually. So I also have it here on the slides. Variables, or at least those variables that we cover by now, only live and are valid within their block. And there are also two definitions here, the lifetime and the scope. And scope means they are accessible, and yeah, they are only accessible within their block. And lifetime is where they actually exist, but we may not be able to access them. But in our case, for those variables that we cover here, it's the same. So only in the block where they're created and in the inner blocks.
Mm-hmm. So the lifetime is from the start to the end of the block, and the scope is in the block.
Mm-hmm. And yeah, a block is everything between two curly brackets.
Mm-hmm.
Okay.
So example, the body of the main function, the body of an if, of an else, of a loop.
Mm-hmm.
Mm-hmm.
Okay. Then we continue, I think, on the slides a bit more. And we already thought about it a bit, I think, in the practicals too, I think. We had a short look on the stack, and we also want to view it again now with this function that we have here. And now I have to prepare it, something like that, and this thing here. Okay, very fine. Okay, now we want to visualize what is happening here. And when we start executing the program, so are you my debugger now? Okay, so in the very beginning, nothing exists here. And then at some point, we enter this main function. And now I want to represent this entering of the main function with this block here. So we start on the stack with the main function. It's just some indication for you now, which we do not go into detail. Okay, so we go to the next line, integer age. Okay, so we create an integer which is called age. And this will be put below on the stack. Okay, and then we have this condition. If age is larger equal 18, is that true or false?
It's false.
Okay, so where do we go?
So yeah, after this check, we jump to the else, because this is not executed, but we have an else block, so the else block is executed.
Okay, and we still do not change anything on the stack because we have not declared any further variables. And then we go to line 11. Oh, okay, there is the character adult. Okay, and now the character adult gets added to the stack. Okay, I missed some part here. So we have a character adult on the stack. Okay, and now next line, what's happening?
So then we are at the end of the block.
Okay, so we're leaving the block again, and this last thing gets removed from the stack. And we have again this available, and when we are at the printf, the stack looks the same, and for that reason we cannot access our adult. Okay, that was the stack visualization, and we can also do this now with our debugger, but I think we will leave that as a homework for you because we do not have so much time left.
Yeah, so that's also why it's called a stack, because we put things on the top of the stack. So because the stack grows down from the top to the bottom, and this goes at the bottom of the stack. But we put things on the stack. When we enter this, okay, we have a variable, we put it on the stack, then we exit the block, and then we remove it from the stack again. Mm-hmm. So like always, the last item we put on the stack is the item we first remove again. That's why it's a stack.
Mm-hmm. And the last one got removed because we left this block where it was declared.
Yes, this is the same stack as is meant by what happens when you have a stack overflow. But what that is, we'll probably see later.
How can we fix it now?
Yeah, how can we fix it? I don't really have a slide for that. But do you have any recommendations in the chat?
How can we fix this problem now?
Yeah.
Well, this was the explanation.
Exactly. Declare the variable outside. Mm-hmm. So maybe you can try that and move it up. Okay, we say char adult here, and maybe just give it a value u for unknown. Mm-hmm. And then here, okay, this is not an error, mm-hmm. but This is something you can do in C. You can.
Should we demonstrate this as well?
So we demonstrate it. You can redeclare a second variable here, so which is also called adult in a different block, but it's a different variable. So maybe if you can quickly execute this, you see it's U because we didn't change this adult. We created a new variable called adult.
So I just want to give you the picture now on the stack. This would mean that we have here this character adult, which has the value U, and then we would have this additional character adult in the block, which would then exist a second time, and there we would store the N. And yeah, after we leave the block, this last string gets destructed again, and then we end up still with the U because they do not interfere.
And if we declare the adult variable, so now let's just assign to it. That's an interesting question as well, that if you declare the adult variable at the end, it's too late. Because basically the program tries to execute this, but the variable only gets put on the stack once we reach basically this line here. So it doesn't exist here yet, and it already says, okay, it's an error because, it doesn't exist on the stack yet. And if we declare it up here, we can exit it on the inside.
And now we really got printed the N, right? Yeah. So that's the behavior that we expected. Okay, we have 2 minutes left.
Okay.
Now the question is, should we leave everything that we have prepared for next week? Because this would also fit thematically better, because then you have learned everything from the lecture and you do not spoil anything. And
yeah, I think
it would be better.
Would be a good idea.
But we're still here to answer your questions.
How did I move the code up? If in Visual Studio Code, if you press Alt and the arrow keys, you can move lines around. This is just basically what we did now. If you declare a variable outside of a block, it's available inside, but not the other way around.
So we can access this A. You might run it.
Yeah, we can run it.
So this works.
It works.
Yeah, because A is outside and the inner block we can use the variables, but not from an inner block we can use.
And if you recall, true is 1, so this gets executed.
Yeah.
It should be on the desktop. So VS Code in the virtual machine should be on the desktop called Codium. It's the same.
So why is this not working as you removed character from else?
So this is an assignment, and this is a creation of a variable. If you write the equal sign, the right part of gets assigned to the left part. I think we did that in the last stream. So if you write the type in front here, and we create a variable adult, and if you just write adult, we assign to an already existing variable. That's why if you do this, we get an error because we want to assign to an existing variable, but there is no existing variable. So we get an error here. So identifier adult is undefined. We haven't defined it yet. But if we write char in front, the error goes away because now we are creating a new variable adult and assign this to it. But this is not what we want. We don't want to create a new variable in this if, which will get destroyed as soon as we leave the if. We want to carry the information basically outside of the if block.
The slides will be available on Notion later on, yes. And another possibility that you suggest would be possible, of course, that we can just write char adult without initialization.
But then it's not empty.
Then there can be anything in adult. And let's see what's in adult. Probably 0, but it does not need to be 0.
Okay. You don't see anything. Let's print the number representation. Okay, it's 0, yeah.
But the problem is now it could be anything that is in this variable. And if you forget to initialize it with some value, so for example, you only have an if here and not an if else, then it might happen that that it does not get initialized, which would be problematic, because then you continue with an uninitialized variable where anything can be in there, and your program can really appear to happen kind of weird.
Yeah, so this would be problematic, because if we don't go into this if here, the adult variable is like, we don't know what's in there. Because if we do this, we just say, okay, there is a variable adult, but we don't care about its contents. And now we're printing something where we don't know the content of that variable. If you write an else, this would be fine, because now we can be sure that either it's set to y or to n.
You didn't miss anything here, it's just compiling the results. You saw all of them. Of course we can put the print in if else, but then we have to print, have to write the print twice, but we probably want to avoid it. And there was some question about returning adult. This is not possible here. We cannot return adult because we are not in a function. We are in a function, but we can only return something from a function, but then we cannot execute code afterwards. So in particular, we cannot print the adult.
So if you return in here, then you would return from the main function, and the program would basically stop, because if you return from the main function, the program exits.
Okay. I think then we go to the summary and open the Menti questions, because we're already writing many questions in the chat, so we'll do that directly. So we saw today the Boolean expressions, we also saw the compiler and the debugger, and we also had a glance at variable lifetime and the scope and functions, and more on the stack will be next week. And then you also heard everything in the lecture that you need to know.
Just one thing more. The question was, shouldn't it just return from the nested function and the output function should still run? Yes, that would be true if this was a function, but this is not a function. This is just a block, like a scope, if you want to call it that, like that, where you can run code inside of, but it's not a function. If you return in here, you still return from the main, because you're currently in the main function. But this will probably be more clearer next week.
Okay, then we switch to the Menti. We have to see who won the Menti quiz today.
How do I do
that?
Okay.
And it's such a...
Now we have an animation.
But how... we really got some more animation.
Bill won. Congratulations.
Yeah. Thank you for participating. And continue to the next slide, that we have the questions for you, but we also answer them out of the YouTube chat. And I think there will be some questions, and we have still some more minutes until the lecture starts. I have to look what the 19th is. So this is Sunday. I mean, it would be better if you start earlier, and maybe you start this week, and then you still have a lot of time to study for your tests, and you already finished some part of the assignment, then waiting until the last moment and then do it in the last 3 days. So I would really recommend starting early than starting too late.
Maybe you can just try starting earlier, and if you see, okay, it's really easy, it's going well, then you could say, okay, I'll study for my tests and then finish later. But definitely try at least doing it before, so if it's really, like, if it's hard for you, if you don't manage that well, that you are aware of that you need much time for this.
How many hours does the A1 take for a beginner? It's really hard to say. It could be the case that you finish within some hours if you get the concepts and you really get into the thinking. But it can also happen that you need, for example, 2 days to finish the assignment 1, or even longer if you, if it's hard to get for you, hard to understand what you're doing. So
yeah, it depends so much on prior knowledge and not specific to programming knowledge. If you have knowledge in other stuff or hobbies, I know they might help you learning faster how to think like a computer, which will help you to write the code.
Yeah.
So it's really hard to tell.
Die Infos zur Coding-Session nächste Woche sind im Teach Center, so wie immer schon verlinkt, beim zweiten Blog. Da findest du das Pre-Work und die Termine sind klar darunter. Could you explain how to set up LLVM Clang compiler in a VSL environment?
You just have to install it.
Yeah.
And you will need to figure that out because it depends on the Linux distribution you have in your Windows subsystem for Linux. If you can't figure it out, so I would recommend using a virtual machine.
Yeah.
But if you,
Yeah.
Or maybe if you really want to use it and have some troubles, to ask on the Discord.
Yeah.
But try to Google first.
What topics left on this lesson? Yeah, so we would cover functions, or would like to cover functions more deeply, but we will put this for next week, which is no problem.
So maybe it's for the better because you will see functions again today in the lecture. I think the lecture already talked about them, but it'll be more in depth today. So
is the questionnaire for the assignment held in English or only, or also German? You can always ask questions in German, and we will also be happy to answer questions in German, so no problem there.
You will get to that next week, I think, in the lecture.
How do we configure additional warnings? So when you compile, you have these compiler flags.
I think
on the very top.
Oh, here, okay.
You write those flags to the compile command. Don't get confused what this is now, but it's just to demonstrate what the warnings are.
These are the flags we're using
in the assignment.
In the first assignment. So, yeah. Okay.
Yeah. Go-to is not allowed, and you will get 25% of your points deducted if you use the go-to command.
Yeah, I mean, you can. Codium is pre-installed. You can install VS Code if you want to. So Codium, VS Code is the same thing.
Yeah.
Basically.
So project global variables or general global variables are not allowed in our course, and we will not discuss them yet, maybe at some later point, but you're not allowed to use global variables in the course because
except constant global variables.
But if it's constant, then it's not a variable, so that's why they're allowed. But no global variables allowed in our course. Because you should learn structured programming and not...
Yeah, and because I see it in the chat, there can be some situations where GoTo is more readable, but the general rule is, especially for programming beginners, if you use GoTo, you're doing some stuff in a very unoptimal way, in a way which you shouldn't do. So we just say we prohibit GoTo for you to think more about how can I structure my code in a good way.
Yeah.
The assignment will be released later.
Yes.
Yeah.
6:30. Do you know some in the very moment?
No, except this one.
Yeah, so this is our very good channel to learn programming.
But you can definitely find some good videos.
Yeah. So ESP is online because in December we will switch to offline mode probably, and also in we wanted to do it offline, but it was not possible for us. But next week it will be done.
Especially because Alex is in the USA. It will be especially difficult.
Okay, so we have 4 more minutes, and maybe we go very roughly through the question, but I cannot guarantee that we cover all of them. When something is unclear in the coding sessions, then you probably find a link in the assignment description where you can read through and find some explanations.
Only the standard library. You will learn it later.
Yeah, it's part of the lecture today.
I mean, it's not supposed to have the exact same VM on your PC, because then you would have to sync it somehow, but you can just install the virtual machine on your computer and on your laptop, and we already learned how to use Git, and then you can use Git to synchronize your programming work between those two. And if you always push, then you always have the stuff on the other computer. I did my coding session over 2 weeks ago, handed in all the reports in time, still have received no points and no.
Enough for assignment 1 if you start coding this semester. That's something you look up in the assignment description or in our course schedule. Oh, I don't think so. We should be live.
Are we live?
No, we are not. Where do you see it that we're not live? We should be. Okay, now it's working again.
Hi, sorry.
Maybe
the TU internet.
Okay, but I don't think that there was. I don't know what the questions were about. It was just when the assignment is due, you can find it in the assignment description.
You have to use. You don't have to use, but you should use Codium into a virtual machine for assignment 1. You have to use something, and you should use Codium, but you can use something different if you want to. Yes. Starting with assignment 2.
6:30 today.
Yeah, so the upstream, you will get your personal repository tomorrow. Sometime tomorrow.
Everything is for the practicals. Lecture has only an exam.
Yeah, the lecture is only the exam.
We don't answer this now.
No.
That's too hard.
Yes.
So
the commands basically are the same on macOS. You will get into some trouble later on in this course if you use macOS, but if the virtual machine doesn't work for you, just stay on macOS.
We don't explain it now.
Yeah.
It's too hard.
It's just because there was a question in the chat. Yes, you can use it. You just have to know how to compile by hand. You can say the assignment review. I always just pressed on the compile button.
So how to access the assignment, you will see that in the video at 6:30. You can fail the assignment interviews because there we check that you really programmed on your own. But don't worry, if you've done it on your own, then it will not be a big problem because you will easily manage to do them.
Are we gone again?
Yeah, okay. Okay, okay.
In the coding sessions, I think.
So that's it. And we already answered this. I don't know if we are live or not, but it doesn't matter. The lecture starts now.
Yeah. So
if you see us, have fun at the lecture, and otherwise also have fun at the lecture, and we will meet next week.
Yeah. Bye.
Bye.